So, welcome, boys and girls. Today we're going to talk about radicals. When it comes to radicals, what we are talking about is square roots. And so, anytime you hear radicals, we're talking about square roots. We're talking about things like the square root of 16. We're talking about things like the square root of big numbers as well. The square root of 16 should be a piece of cake. The square root of 16 is 4. And that is something that you already know before, right? The square root is basically asking you, give me a number that I can square to be the number inside of the square root, right? And so we need to choose 4 because 4 squared is 16, and that's the number inside there. So that's all good. Now, obviously, you're not going to be asked to solve questions like this because you already know how to solve questions like this. This is the basic function of what a radical does. But this is not what we're going to be up to this week. We're going to ask more difficult questions, like, for example, what is the square root of 20? Now, if you know your perfect square numbers, like many of you do, you're probably looking at this square root of 20 and thinking, there is no square root of 20. The square root of 20 is not a perfect square. Okay, I know that 4 squared is 16. I know that 5 squared is 25. And 20 is in the middle of there. And so it would be something like 4.312 squared maybe, but it's not going to be a nice, easy number, right? 20 is not a perfect square number. If you're thinking back to last week when we did difference of squares, 20 is not a perfect square. So we could not use that for difference of squares. Now, a little bit differently, as I undo all of this stuff, you're 100% correct. 20 is not a perfect square, but what we're going to ask instead is, can we take the square root of part of 20? Instead of square rooting the entire thing of 20, can we do the square root of just a certain half of it or something like, can we just take one piece at a time and do the square root? And so we're going to get comfortable with this process. I'm going to work through it now, and you'll do this a whole bunch. We're going to take 20, and we're going to split 20 into 2 numbers that multiply together. Now, you can pick any 2 numbers that multiply together to make 20, but you don't want to pick 20 and 1 because that doesn't really get us anywhere. What are 2 numbers that multiply to make 20? What do you got? Okay, 2 and what? 2 and 10, 100%. 2 and 10. Do these 2 numbers multiply to make 20? Yes. Now, can we continue breaking down 2 into 2 different numbers that multiply to make 2, and breaking it down into 2 and 1 would be a waste of time? No, we're basically stuck here, right? 2 is a dead end. 2 is 2 times 1, and that's it, right? 2 is prime, and so this is the end of the line here. Over here, can we continue to break down the 10? Yes, of course, the 10 is going to be 2 times 5. Now, what about this 2? Is this 2? We've already decided that 2s are dead ends, so we're done here. What about this 5? Is this a dead end? Can we break down 5 into 2 numbers that multiply to make 5? Right, 5 and 1, but no reason to do 5 and 1. So what we've done now is we have done a little factor tree, and we've split 20, and we're going to look at all of these dead end numbers, okay? 2 and 2 and 5. Okay, what this is, 2 times 2 times 5 is 20. Okay, that's another way to write 20. Technically, when you take college math, this is going to be called the prime factorization, right? You take 20, you break it all the way down until it's all primes. 2 is a prime, 2 is a prime, 5 is a prime. And we like prime factorization because these 3 primes only make 20, of course. You can't take these 3 numbers, multiply them together and make 8. Doesn't work. And 20 can only be shown as these 3 primes, right? I'm going to do something really quick. But if I go back and I break 20 into 4 times 5, which is 2 times 2, dead end, dead end, dead end, I went a totally different way, but my dead ends are the exact same numbers, right? 2 times 2 times 5. So no matter which way you go, you're always going to get the same numbers as you make your way through there. So we like this. Now what we're going to do is we're going to try to do the square root of 20, And that means we need one number multiplied by itself. And so if you look at this, 2 times 2, that is a perfect square. And so this portion of 20 is a perfect square. Now this portion is not a perfect square. This portion has no other 5 to make it a nice match. And so this is how we're going to solve this question. We're going to basically take the square root of this. Now 2 times 2 is 4. The square root of 4 is 2. So basically if you have two 2's, you're going to have one 2 that gets to come to the outside of the square root, okay? And then left over on the inside of the square root will be anything that doesn't have a match. So the 5 gets to stay on the inside. This is the process we're going to be doing. It's really not too difficult. I was going extremely slow there as we walk through this. Let's get another question. I guess I'll just do black again. Let's do a question like the square root of 60. Okay, so for the square root of 60, we want to break it down into numbers, and I'm going to go fast so we don't waste too much time here. 60 can be 6 times 10, 2 times 3, 2 times 5. Now again, if you did 15 times 4, totally fine. You would have gotten the same exact leftover dead ends. And so we want to focus on these 4 dead ends, okay? Important to remember that this 6 is not a dead end. We're not thinking about the 6. That's not a prime number. This 10 is not a prime number. So we're only focused on these 4. Are there any that we can match up with pairs, and that would form a perfect square portion? Of course, these 2 are perfect squares. So what I like to do is circle the pairs. And whenever you have a pair of 2's, one of them gets to come outside. Okay? And so we're going to have the 2 on the outside of the square root. And then whatever you have left over is stuck on the inside. Okay? It does not get to be square rooted. 3 and 5 are left over on the inside. And you're always going to use multiplication when you do this. Okay, so if it's 3 and 5, we're going to put 15 inside here. And that's it. That's the whole thing. Break the numbers down, circle the pairs, piece of cake, and you'll move from there. Now, important to mention, I'll be quick with this point as well, but square root of 60 and 2 square root 15, these are exactly the same decimal. If you type this in the calculator, it will tell you a decimal. If you type this in a calculator, it will tell you exactly the same decimal. Okay, what we're doing is simplifying. We're not changing things around, so these should still be the same. That's also a good way to check your answer, by the way, if you want to do that. Now, one last question. Let's spice it up quite a bit here. Let's do the cube root of a number like 24, which is kind of a small number, so it won't take us very long. We want to break this up. 24 can be maybe 8 times 3, which could be 2 times 4 prime, not prime, 2 times 2. And again, we don't need the 8. We don't need the 4. We only need the dead ends. We've got 1, 2, 3, 4 dead ends. And so 2 times 2 times 2 times 3 equals 24. So the big difference with this question, though, is that we have cubes. We have cube roots. So that means we need 3 things that multiply together that are the same. And so the only difference of this question is what? Yeah, the 2's, we got to circle all 3 of them, right? Because we need cubes, and so we need triples, basically. So we circle all 3. If ever you circle something, only one of them gets to come outside, because basically this is 8, and the cube root of 8 is a 2. And so we have a 2 on the outside, and then the 3 is left over, so it goes on the inside. Now, you'd want to make sure, a lot of times students forget this when they're doing it by hand. They write their answer like this, and that's not quite right, just because we have this cube here. So don't forget this little cube on your 3. But that's it. That is how to simplify radicals and work through radicals. If you can get good at this, then you're pretty much in a really good spot to get great grades when it comes to radicals. Now, there's one more thing that I want to talk with you guys about that I want to make sure we have a chance to go over it. So I'll zoom in right here, okay? If we have the square root of negative 25, okay? So I'll make a little box here so we can focus just on this little portion. The square root of 25. But it's not the square root of 25, it's the square root of negative 25. The good news is we know that this number right here, the square root of 25, it's going to be 5 something, right? Because 5 times 5 makes 25. So we know that 5 is a good choice, but we don't know, should we pick positive 5 or negative 5, right? Which one of these makes the better choice? Maybe this white color is easier to see. So if we choose positive 5, that means we need positive 5 squared, and it has to equal negative 25. Positive 5 squared is 25. That doesn't work. If we choose negative 5 squared, and if you do it in a calculator, you need parentheses like this, negative 5 squared is also 25. And so you have to ask yourself, is there any number that we can square that will equal negative 25? No, there's not, right? It would have to be a 5 if we wanted to make 25. But we can't choose positive 5 and we can't choose negative 5. The only thing we could choose is if we chose one of each. But that's not squaring, so that doesn't work either. And so is there any choice we could make? No, there's literally no choices that we could make. And so this right here is impossible. The square root of negative numbers it doesn't make any sense. Hopefully that makes sense to you guys as you think about it, right? You cannot have the same number multiplied together and equal a negative. Because if it's plus plus, you get plus. If it's minus minus, you get plus. Same number, you get plus, period, every time. So this question right here is impossible. Now, this gets a little wacky, if it's not wacky already, because if we have the cube root of negative 8, I guess, we know that the cube root of 8 is 2. Let me put a question mark here so that we don't know what goes there. Sorry. The cube root of 8 is 2. And so again, we don't know if we should choose a positive 2 or a negative 2, right? Which one should we choose? If we choose a positive 2, plus 2 times plus 2 times plus 2. That would be 4 times 2, which is 8. And that's not going to work. But I'm sure a lot of you are working ahead of me here. If you choose negative 2 cubed, that would be negative 2 times negative 2 times negative, forgot the negative, times negative 2. Does this work out? Negative 2 times negative 2, that makes positive 4. And then we take this and we multiply it by the last negative 2, and we are going to get negative 8. And so square roots of negatives, impossible. Cube roots of negatives, not impossible. And that is like a very weird difference and kind of a hard thing to remember. But hopefully this is a good proof to you why that happens. Okay, 2 positives, 2 negatives can never make a negative. But if you have 3 negatives, it does make a negative. So that's the whole idea. This whole thing here, working with radicals, working with simplifying radicals, is really big. If you're good at this, then you're going to be good at radicals probably. We're going to stop this lesson here, maybe upload another one, but hope this helps.